Hello everyone! Did you know that some basic chemicals used in our daily lives serve the purpose of indicators? For example, red cabbage, blueberries, etc. Let's see some of these indicators. All of you must have tasted at least one of the following substances, that is, lemon juice, vinegar, tomato ketchup, etc. at some point or the other. How do they taste? All of them are sour to taste. Why is that so? That is because they all contain an acid of one sort or another, and almost all acids are sour to taste. On the other hand, substances such as detergent, soap, and toothpaste contain alkalis, which are bitter to taste and have a soapy feel. It would, however, be too dangerous to taste a substance just to find out if it's acidic or alkaline. Chemists use certain special substances called indicators to check the nature of a variety of substances found all around us. We will learn more about these indicators with the following learning objectives: indicators, the most common natural indicators, and a universal indicator. Indicators. There are substances which change their color when added to an acid or an alkali. Many indicators, such as litmus, red cabbage solution, etc., are colored substances which are extracted from natural sources like plants. Litmus is the most common indicator used in chemistry. It is obtained from plants called lichens. Coarsely powdered lichens are allowed to soak with ammonia, potassium carbonate, and lime. The solution is stirred regularly. After about 4 weeks, the color of the solution changes to bluish purple. A paper is dipped into this solution and then dried. This is called blue litmus paper. When it is dipped into an acid like dilute HCl, it turns red. Another type of lichen is used to prepare red litmus paper. When this red litmus paper is dipped into an alkali, such as dilute NaOH, it turns blue. Red cabbage pH paper is another natural indicator made from red cabbage. Similarly, cherries and grapes too give natural indicators. Some other commonly used indicators include phenolphthalein, methyl orange, and methyl red. These indicators give only 2 different colors. For example, phenolphthalein in a basic solution like dilute NaOH turns pink, and in an acidic solution like dilute hydrochloric acid remains colorless. Thus, they are only able to indicate whether the substance is acidic or alkaline. In contrast to this, another indicator called the universal indicator gives a wide range of colors and is used to understand how acidic or alkaline the substance is. It is a mixture of many indicators and usually has the sodium salt of phenolphthalein, methyl red, thymol blue, methanol, propanol, etc. A reference color card called a pH scale is provided with each universal indicator. It runs from 0 to 14. A substance with a pH less than 7 is acidic, while a substance with a pH of more than 7 is basic in nature. A substance having a pH of 7 is neutral. Let us check some everyday substances using a universal indicator. Arrange a set of test tubes as shown, filled with different substances such as lemon juice, apple juice, milk, pure water, toothpaste, and lime water. Add 3 to 4 drops of universal indicator to each of these test tubes. Observe the change of color in these tubes. Compare these colors with a pH scale. You will notice that lemon juice has a pH of about 2, which makes it the most acidic of all these substances. Apple juice has a pH of around 4, while milk showed a pH of 6.5. All these substances are acidic in nature. Pure water is neutral with a pH close to 7, whereas toothpaste having a pH of around 8 and lime water with a pH of 10 are basic in nature. For more accurate measurements of acidity or basicity, an instrument called a pH meter is used. Indicators are found abundantly around us. Onion juice, along with other household items like vanilla essence and clove oil, can also be used to find the nature of a medium. Surprised? Let us find out. Let's take some onion juice in 2 beakers. We are all aware of the peculiar smell of this juice. Well, this smell is attributed to the presence of propanethiol, a slightly acidic compound. Let us add some dilute hydrochloric acid to the first beaker. Propanethiol in the juice, being acidic, does not react with the HCl, and the odor of onion juice thus remains as it is. However, when a few drops of a base like NaOH is added to the second beaker, propanethiol gets neutralized by the base. As a result, propanethiol loses its odor. Thus, onion juice can be used to identify the acidic or basic nature of a substance by detecting any change in its smell. Such indicators are called olfactory indicators. The same thing happens if we take vanilla essence or clove oil instead of onion juice. The smell of both vanilla essence and clove oil is due to the presence of slightly acidic chemicals, which gets neutralized in a basic medium, leading to the loss of their peculiar odor. So, we can infer that olfactory indicators maintain their odor in acidic solutions and lose their characteristic odor in a basic medium. Such substances that indicate the nature of a medium by a change in odor are known as olfactory indicators. Some common olfactory indicators that can be found in common households are onion juice, vanilla essence, and clove oil. To summarize, indicators. These are substances that change in color when added to an acid or a base. Litmus is the most common indicator used in chemistry. It is obtained from plants called lichens. Universal indicator. It is a mixture of the sodium salt of phenolphthalein, methyl red, thymol blue, methanol, propanol, etc. Olfactory indicators are substances that indicate the nature of a medium by a change in odor. Common examples of olfactory indicators are onion juice, vanilla essence, and clove oil. We learned how indicators help us in categorizing acids and bases. But did you know that we have indicators to separate 2 or more acids or bases from each other? Well, stay tuned to learn more.
Keep imbibing. We believe in you.